So Redis and artificial intelligence. So today we have several experimental modules that deal with artificial intelligence. The first one is Redis ML for serving machine learning models which were trained with other platforms. The second one is Redis TF for serving TensorFlow models. And the last one is Neural Redis for training and serving basic DL models. But we always thought that we need a production-ready, cutting-edge module that can serve effectively ML-DL models which were trained by leading AI platforms. So today, I'm very proud to announce Redis AI. Redis AI is a new module which was jointly developed by TensorWorks and Redis-Labs. And to talk more about it, I would like to invite to the stage the CEO of TensorWorks, Luca Antiga. Luca, please.
Thank you. Hi. So TensorWorks is busy creating the tools for the new wave of data-defined software development. And Redis AI is the first example of that. Putting AI in production is one of the challenges of DevOps today. You have new workflows, new compute that needs to be served everywhere, from large scale to small scale, close to the data or on the cloud. That was maybe developed with different frameworks. TensorFlow, PyTorch are the leading ones, but there's a number of others. So you don't want your decisions on what framework to use to interact with your decision on how you deploy those models. You want to keep your data with computation because your stack has to be as short as possible to be cost effective and operationally easy to manage. And of course, we want to leverage infrastructure that has been built since 10 years, for example, all the operations around Redis and Redis itself. So that's what we looked for when we decided to go ahead with this project together with Redis-Labs. So we took Redis and we added a new data type to it, which is a tensor. For those of you who are accustomed with deep learning, tensor is a multidimensional array that contains numbers in a very efficient representation in many dimensions and in the indexing space. So now you can set, with Redis AI, you can set a tensor to a key and get the tensor back. And then you can set a model that was developed with PyTorch or TensorFlow, or in a short time with basically any other framework, because there will be support for Onyx, which is an interoperability standard in the deep learning space. And Onyx also supports traditional machine learning models with Onyx ML. So you will be also able to set a random forest model or a support vector machine inside Redis and run it on the CPU or GPU or multiple GPUs, all without having data or go out of Redis to do that. And not only that, PyTorch supports an interpreter of tensor operations. So it's called script in PyTorch. And we took script, we put script inside of Redis, and now you can set a text file, like text, a field to a key, tell Redis it's a script, and then run that script against other tensors in memory on the GPU. So you can do GPU computing without actually touching TensorFlow and PyTorch directly in Redis. And you can do it at scale with a master replication or cluster. So for example, use case, let's see why it is important to get an answer, but also to be able to keep your data on Redis while you're running your models. Say you have this nice cluster of Redis instances, and you have a chatbot that you want to deploy. Chatbots nowadays are done in many ways. One of them is a sec-to-sec model, which means you take a sentence, you feed a recurrent network with the sentence. The recurrent network, word by word, builds a vector of numbers that represents the content of the sentence, the semantic content of the sentence, and then a decoder. After that, it's a network that is more or less symmetric with the ones that encoded the sentence into numbers, takes those numbers and encodes a sentence as a response. So you have an input, an output, and a state. And that state represents the state of your conversation. So you can now convert your words into numbers and then send them to Redis. You get an answer, but you also get a state, which is your state of a conversation, which is not much different than a state from an interaction with a web service. It's the same concept. And now Redis can store the state within the instance, but also it can distribute it to the replicas, for example. And what happens is that Redis instance goes down. Well, Sentinel will elect a new one containing the state of a conversation so your conversation can continue. And this kind of clarifies why it is important that DevOps dealing with AI leverages on technology like Redis, as we tried to do. Now, let me show you a little demo, hoping that everything works. We took a very nice tutorial from PyTorch, just so you can replicate it. It's in the PyTorch website. And built something that's deployed on Redis with a chatbot. I don't know how the chatbot will behave. Well, I kind of figure out. I'll try it before, but we'll see. So this is how you start Redis with the Redis AI module, just load module. At this point, Redis can talk tensors. So if you fire the Redis CLI, you can set a tensor this way. AI tensor set, foo is the key. Then the type of the numerical representation of the tensor, in this case it's float 32-bit. The shape of the tensor, 2x2 matrix in this case. And then you can provide either a blob, a binary blob, or just values in the form of numbers. So now we have a 2x2 matrix containing 1, 2, 3, 4. And you can get the values. So this is a very easy way of dealing with tensors. Now, I have a very tiny application here serving this chatbot. This was developed by Sharon Thomas, who's working with us at TensorWork. If I'm contacting the chatbot, nothing happens because Redis doesn't have any network in it. So let me install the encoder on the CPU, because this computer doesn't have an NVIDIA GPU in it, and the decoder. OK. So let's say what happens.
Hi.
Wow. What is that? How are you today?
Fine.
Wow, nice. Great.
Yeah.
Yeah. OK. That's a very engaging conversation. But we trained the model a bit more. And we have an encoder B and a decoder B that we want to install. Now, at the same key, you have another network. Let's see what happens. Hi, Redis.
Hi, Roses.
Oh, this one is smart. So, how are you today?
Okay, I'll have a walk.
OK. Where to?
Out of here.
OK. I think I'm done. Thank you.
Thanks much, Luca. So it is also very important to note that Redis AI runs where the data lives. And to demonstrate the importance of that, I would like to show you the following example. So let's look at a credit card transaction scoring. We are all familiar with that. When we go to any point of sale, we give our credit card, we enter our PIN, and then we need to wait for the verdict. Yes or no, right? Now, what happens under the hood is that the transaction goes to an app server, and the app server uses two resources. The first one is a database which hosts all the profiles, users' profiles, merchants' profiles, geographic profiles, et cetera, et cetera. And then there is the AI serving layer, which is basically the decision algorithm. So typically, the app server sends a request to the database, bring me the applicable profiles, and then the app server vectorizes the profiles and send them to the AI server for the decision engine to come back with the verdict, yes or no. Now, all this can easily take 200 milliseconds. And this does not include the round trip over the internet from the point of sale to the data center where the app servers reside. This is how we do it today. Now let's see how you can do that, the same thing with Redis AI. So here, basically, all the users, merchants, geo profiles, etc., will be hosted in Redis, and the decision algorithm will be in Redis AI. With a single API call, you basically approach Redis, give me the result, and you get the result, yes or no. This will take approximately 15, even less milliseconds, which is 15 times faster than any other system of today. Isn't it impressive? I think it is.